So as Will said, my name is Eric. I am with Eversource, the company that was probably tearing up Audrey Street that day.
Yes.
Maybe, maybe not.
I didn't say that though.
I'll say it, it's fine. So I work in the Clean Technologies department at Eversource. So what that means is I look at all gas decarbonization technologies. I cover renewable hydrogen, renewable natural gas, and networked geothermal in this case. For those that are unfamiliar, Eversource, we're one of the big utilities up in New England. We cover 3 states. We've got gas, water, and electric service, about 4.4 million customers. So we're decently sized in terms of utilities. So I'm here to talk about, what does this actually look like when you go out and try and do one of these projects? Audrey gave us a great background on sort of the ground roots effort, what the impetus was and how we sort of got the technology going. Then some, great talk about what the actual technology implementation looks like, how we can do drilling, what the heat pumps look like and how they work. But I was charged with actually putting one of these systems in up in Framingham, Massachusetts, and so that's where it gets real, is when you're given a budget and approval from your regulators to go build one of these. So back in 2020, we proposed in a gas rate case to do a demonstration project of a networked geothermal loop. We went to our regulators and said, hey, we'd love to try putting one of these in. We think it makes sense as the gas utility to do this. And here is what we're proposing in terms of size. We said, hey, 300 tons seems like a good starting size for us. And they agreed. They gave us approval to go ahead with it. They approved our budget, and we started looking at sites within our service territory that we could physically build one of these. We put together a bunch of screening criteria and ultimately landed on the city of Framingham. It's a little bit west of Boston, but it's a great mix of urban but not downtown Boston and Cambridge urban type environment. So we have some commercial businesses, we have some low-income housing apartments, and we have some residential homes that are all kind of included in the area. And really what we were looking to do is answer a number of big questions as the utility. First of all, is this a good alternative to traditional gas service? Is this something we can provide to the customers that they are going to want, that they are going to actively transition over to if we say you can have, your traditional service that you're on now, or you can move over to this networked geothermal system? What does the business model look like? Because we as the utility, it has to make financial sense if we're going back to our regulators to tell them we want to keep doing this. We can't say, hey, the numbers don't work, but let us keep going anyways. So we had to come up with a business model. But then also important are things like, what do the energy savings look like, both for us running the system and for our customers, their day-to-day energy bills. What's the maintenance, the operations of a networked geothermal system look like? And then how does the shared loop actually work from an efficiency standpoint? Because us being a mixed utility, both gas and electric, we have the benefit of being able to see the electric grid as well. And there's some big implications around electrification in general and how much build out we have to do to accommodate that future load. Technologies like this have the benefit of being so efficient that we may be able to use them to offset the amount of build out that we need on the electric side and go back to our regulators, and that's another feather in the cap to say this is why these make sense. This slide, and apologies that it's a little bit fuzzy, but this is an overview of our loop as it stands today. The project itself is about a 1-mile loop through a neighborhood. It's an 8-inch pipe running in the street, does a single continuous circuit, and then there are 3 distributed bore fields. You can see one on the northwest corner there, one about midway down, and then another on the east side. You'll notice the one on the northwest corner looks a little bit different than the other 2. That's because that one is actually drilled with deviated boreholes versus traditional vertical. So you can see they spread way out from a central point, whereas the other 2, which account for the other 50% of the load on the loop, are much more dense and packed because they're going straight down rather than out. Customer-wise, we have about 140 customers that are going to be attached to this system, and that breaks down into roughly 24 residential homes, 5 commercial buildings. It's a mix of local small businesses, a fire station, a community college, and then 10 low-income subsidized apartment buildings that are 12 units apiece. So we have a really great mix of different customer types, different load types, and more importantly, we have different fuel types on the system as well. So we have gas customers, we have electric resistance customers. All of those low-income apartments are still on strip heating in the walls. And then we have some delivered fuels, oil and propane customers as well. And that's great because we're going to be able to compare energy costs across all of the fuel sources and really draw some great conclusions on how much customers will save depending on what type of a system they are converting from. So what does the construction process actually look like here? We broke it out into kind of 3 buckets. This helped because we could kind of compartmentalize the different companies that specialized in building each parts of the system, and we could also look at where our embedded skills as a utility could really come into play here, specifically around those horizontal loops, the second one on the list here. The vertical loops, those were totally brand new to us as a utility. We don't typically go out and drill holes down into the ground unless it's a geotech hole, and those, maybe you're going down 15, 20 feet sometimes. We had to pull in outside construction firms, outside drilling firms, and really make sure we had experts drilling those vertical loops. The horizontal loop, we were very familiar with. This is exactly the same as gas pipe. We're putting mains in the street, we're pulling services to each of the buildings, and we are installing kind of up to the foundation, or in this case, you come directly inside the foundation to a pair of shut-off valves. And then finally, the customer installations, which consist of weatherizing, making the buildings as energy efficient as we possibly can, potentially running ducting, doing electrical upgrades, and then ultimately installing the heat pumps themselves that will provide the heating and cooling to the customers. Diving in a little bit more deep, I know people love to see photos when you've got an active project underway. Again, these are a little bit fuzzy, but those are shots of the drilling from our 3 different bore fields. You can see on the left there's actually deviated drilling going on with the rig being at an angle. And then in the middle and on the right are the 2 traditional fields that we drilled. In total, all of the drilling finished up. I want to say it was about last week. We completed the last borehole. Maybe it's this week, it's ongoing. So we just got there on drilling. In total, we started last August, so it took a while. These holes aren't necessarily quick to put down, but all things considered for a first time, it went relatively well for us. Main installation, this was much more straightforward. You can see here some photos of the actual pipe that we're using on the left there that says geothermal in white on it, so that in the future, if somebody digs it up, they know it's not a water line, they know it's not a gas line. And then on the right, you can see what the installation method actually looks like. Anybody who's seen a water main go in or a gas main go in, this is exactly the same. We dig a trench out, we lay a piece of pipe in, we fuse it to the other pipe that's already in the ground, and then we just continue building it out from there, trenching, fusing, backfilling, and then moving down another 20 or 40 feet, depending on where we're working. This work was all finished up last month, so as of today we have all of the pipe in the ground, we have all of the boreholes drilled, and we have all of the services pulled to each of the homes. As you can see here, those get a little bit tricky sometimes. You've got to go under some retaining walls in the sidewalk, you have to navigate driveways, other utilities, but fortunately it's another activity that we do day in and day out as the gas utility, so it was a very natural transition over to pull geo lines instead of gas, water, or electric conduit. All of the pipe going in is HDPE, as was mentioned before. High-density polyethylene, exact same fusion techniques and exact same installation. We were actually even able to use some of the fittings off the shelf that we have for the gas side of the business. If we needed a service T or we needed a shutoff valve, we could literally go into our stock room and pull one of those to use on the project if we absolutely had to. Lastly, installation depth. It is a little bit deeper than traditional gas work. We're down at 5 feet in this case instead of 3, and that's mostly for protection of the system and thermal performance. If you get too shallow, the frost line in Massachusetts is about 36 inches, and you'll start seeing some degradation in performance because you're losing too much heat to the ambient atmosphere. So looking forward, unfortunately my system isn't up and running quite yet. We're looking at being in operation here sort of the end of Q1, maybe the April-May timeframe. What we're doing right now is we're in the process of setting our pump house. This is sort of, you can think of it like the heart of the system. It contains central circulating pumps to go through all of the mains, as well as a lot of the instrumentation for control of the system. Temperature, flow sensors, a SCADA system so that we can see it real time. So in addition to the installation of that, we're also working on all of those building conversions that I mentioned, that third work stream in the construction process. If anybody is familiar with the Northeast, the building stock up there is anything but easy. We have a lot of very old homes, very poorly insulated, drafty. Some of them are wood construction, some of them are concrete, we've got brick, we've got all kinds of building materials. And so it has been a real challenge to go into each of those homes and figure out, how do I get a ground source heat pump in here to condition this space appropriately? Can I run ducting? Do I need to put in mini splits or split heads to get certain parts of the building? It really has been an exercise in coming up with creative solutions, but we have a plan for each of the buildings. We have an idea of how we're going to do these conversions, and now we just need to get in there and actually install the equipment, which will take place over the next few months here. On that note, here are some photos of some of the existing systems that we've found within our customers' homes. Some people have a great high efficiency system, but unfortunately that one you see there in the middle is attached to hydronic baseboards. Can't reuse those with our heat pumps because they can't provide cooling, and that's one of the big benefits to the customers, is that they're getting central air conditioning as well. So in a case like that, we have to disconnect the furnace, we have to put a heat pump in beside it, and then we have to figure out how we're going to pull ducting throughout the house. In other cases, on the far left there, that's an electric baseboard unit that's plugged into one of the homes that we're essentially just going to disconnect and then hook up our system to provide heating and cooling instead. Once we do have all of the construction complete and we're up and running, we'll enter a period of operations on the pilot. Our approval from our regulators was for 2 full heating and cooling seasons, so we'll run the system for 2 calendar years and collect a lot of that data that we're going to need to answer the questions that I talked about at the top. You can see here on the bottom, this is a snapshot from another system somewhere else, but this is essentially what our operations overview will look like once we're up and running. We'll be able to see flow rates, we'll be able to see temperatures, we'll be able to tell if buildings are pulling heat off of the loop or putting heat back onto the loop, and then we'll also be gathering all of that at our central pump house and have that data available for analysis going forward. One last point that I like to mention around the project, which is not necessarily which is not necessarily construction or implementation related, but it's the customer aspect to it. One of the things that we found going out and putting this system into this neighborhood is a lot of people just don't know about ground source heat pumps. They don't know what the benefits are. They don't even know what the technology is. And so customer engagement was a huge part of this project, because we realized that really it's a matter of education. We need to get out there and tell them what we're doing, tell them why we're doing it, and why it's beneficial. And the response from the community has honestly been amazing. People are extremely supportive. You can see on the left there, there's a little tent. We had a community liaison who would sit out in the neighborhood and actually field questions to anybody who wanted to stop by. And by the end of her summer out there, they were bringing her baked goods and coming to say thank you. And it was really impressive how positive the members of that neighborhood became as they learned more. But we also did things like presented to the city council and sent out weekly updates to all of the project participants to really make sure that the community was as comfortable as they possibly could be with this first project, which will just pave the way in the future for doing more of these in other parts of Framingham as well as cities and towns throughout Massachusetts. So finally, just to kind of wrap up the project implementation part of this presentation, these are the success metrics that I'm really going to be looking at moving forward. And they're broken out into a combination of some of the hard and measurable metrics, like what are the actual costs to put this system in? What are the costs to run it? What's the operations look like? What does the maintenance look like? What are the environmental benefits? We're going to actually measure pre and post carbon emissions for all of the buildings on the loop. And as of right now, I'm expecting they're going to drop by something like 60 to 75% depending on the original fuel source. But then there's some of the more soft metrics, like what is customer acceptance of the technology? Once somebody gets this into their home and they run it for 2 years, how do they feel about it? Do they like having the air conditioning included into their unit? What do they miss about their old systems? What can we improve to, make it better in the future for additional customers? So we're going to gather that data as well, mostly through surveys and community outreach. And then we're going to compile everything into a report to essentially pitch the case to our regulators that these systems do make sense to deploy from a technology standpoint and from a customer standpoint. And that'll kind of give us what we need, I think, to go back and really turn this from a pilot project into more of a program that we can then provide as an additional option to traditional gas service. So that was all I had for slides, I believe. This might be onto your last slide here.
You can present that one if you want, if you feel that way. But
Oh no, but happy to take any questions on the project itself. If anybody has them, I'll do my best to answer.
The second one's already started.
Yeah, I should mention, we did also win a DOE grant with HEAT and the City of Framingham to actually look at expanding this initial loop. So we're in the feasibility and design phase right now, figuring out exactly where we would run it and what the loads would look like. But theoretically, about a year from now, we should be considering building an additional section onto the west side of that loop, potentially, and hooking on another set of customers to demonstrate expandability.
Which should increase the efficiency of the whole system, because then you get more load cancellation, more heating and cooling on both sides to do that, and then also reduce the cost per customer. And National Grid, which is the other major utility in Massachusetts, is also installing systems too.
Yeah.
Something that slipped through all four cracks here is that I think all of us mentioned that there are federal tax credits under the Inflation Reduction Act. Those are now payable to non-tax-paying entities, which means churches, public school districts, universities, state universities, you name it, can receive these tax credits as a direct payment from the IRS, up to actually 50% perhaps. We're working on the details of the 40 and 50%, but the 30% is locked in for pretty much anybody that wants to request a tax credit for a geothermal project, whether it's a neighborhood, a house, a school, or an entire university campus.
And it's a bipartisan bill with about a 10 to 12 year horizon.
Right.
So do it now.
Yeah, you've got about 12 years left.
And it's why a lot of universities are moving towards this really, really quickly.
All of the Ivy League schools, every single one of them, and many state schools. All State University, I think, is the first 100% geothermally heated and cooled university, which is massive.
So we should all learn from our schools.
Yeah. Anyhow, there's a lot going on. And this slide here, I just plugged in at the end. This is, as somebody thinking about retirement, this is what I want to leave behind, is I want my grandchildren to walk into a house and not only expect broadband, electrical, sewer, and water, but geothermal connections to their first house that they buy. And they're not born yet, so you've got some time.
I'm working on it.
Question is the heat pump itself, what are the limits as far as temperature?
We can operate a ground source heat pump with 28-degree water. We can heat a building. And when we get to around 105 degrees, we start to run out of ability to cool a building. So that's the source water. But as far as making heat, 120-degree water is easy, standard. That's what we do. and 100-degree air and 50-degree air is kind of normal.
And you can always step it up beyond that if you have, say, domestic, you have like cafeteria where you have to have the water temperature higher.
I was curious because years ago, where I live, it's cold. And so they always was talk that, well, yeah, that heat pump is great, but when it gets to 20 below, or 10 below zero, we have to supplement, because it will only heat to a certain point, and they have to supplement. So my question is that still the case, or have these heat pumps
Well, you-
got to the point that
All the manufacturers, yeah.
you can do the whole heating during the heating season? The cooling I get, because it's 50 degrees, we only want to be at 68, right? So the cooling, I get the cooling side of it, the heating side of it. If we're at
Right.
28, or
And
down
an air
to
source,
80,
an air source heat pump starts to either run out of capacity or efficiency or both, down around zero. You can make 100% capacity, but your efficiency is going to go way down, typically. A ground source heat pump can operate happily at 45 below zero with no supplemental strip heat if you design your underground heat exchanger to do that. That might take an extra hole or two, depending on, like for your house. In Buffalo, New York, we have several thousand units installed that we monitor again every 10 seconds with a single 500-foot hole. And those are all 5-ton units, and there's no creep on that. So Buffalo, 30 below zero, bad weather, windy, old 1970s homes, doing fine without strip heat.
Because you're pulling the temperature from the ground, which is a constant temperature,
Yep.
right? It's not, even if the air in Buffalo is at, negative 10, the ground is still that same constant temperature of somewhere in the
You're
50s.
58, yeah.
And for context, our designed system here on the design day, the coldest day in Massachusetts that we're expecting, the loop temperature will never get below 39 degrees in the worst case. So we should range between about 40 and a little over 70 in the middle of the summer and keep that nice tight band year round.
To give one more example, in Whisper Valley during Superstorm Uri, when the outside temperature went down to, what was it, like 10 degrees here?
It was zero-ish.
Yeah.
So way below what anybody's expecting here. The ground loop temperature of that, the water in that horizontal loop lost 1 degree of temperature. So that's it. It's fine. The heat pump will continue to work extraordinarily happily with the temperature going just 1 degree difference, right? Nothing.
You folks have been very kind. I think there's almost as many of you as there are of us. But perhaps at the next EUEC we'll have 100 people in here to tell the story. I really want to thank my panelists for coming from all over the country, and Eric, great presentation. But we're done, and we'd love to stick around if anybody has questions. But thank you for coming.
Not all at once.
Yeah.
I was late, so you might, or at least the people, what would be the time to return for this project?
So in this case, it's hard to give us a quick answer on that because the way that we are funding it is just a straight rebate from our ratepayers. Essentially, we take all of our costs, we submit them to our regulators and say, here's what this costs, and we get direct payment back for it. If you take the tax credits into account, what I'm trying to do now is come up with